Okay. See, I think in a last set of lectures, what we learned was how to improve accuracy of a machine learning model, and we have seen this stepwise process, which are related to, some are related to algorithm aspects, some are related to understanding the model preparations phases, and some are related to improving machine learning accuracy by looking at the data. Okay. So now what we'll do is, there are few algorithms. If you recall till now, what we have been doing is, we just saw linear regression. Then during the Vector series, I explained you some algorithms, right? Some basic algorithms, but that was just a superficial. What we will do is today is, we will now explore some of the very fundamental types of algorithms which we use in machine learning. And see, these are not the only algorithms used in machine learning, but these are some of the very mostly used and majorly used algorithms. Any further algorithm, if it is there, it is most probably some adaptation of what algorithm types which we're going to study now. So why to study the types of algorithms? Can anyone tell me their guess? So we're going to look at types of algorithms. So types of algorithms in ML. So before we move further, can anyone tell me why it matters to us, or why we have to study types of algorithms? Why it matters? So we have few types of algorithms. Let me list them one by one so that you will be able to understand. The first one is, if I'm not wrong, which we have already seen, are based on regression. Okay. And the second type of algorithms are sometimes called as Bayesian algorithms. Okay. And third type of algorithms are called as decision tree based. I might call it as learners or algorithms. It doesn't matter much. Decision tree based algorithms. And fourth one are clustering algorithms. And fifth one, can anyone guess? Is there any fundamental time which we missed? What is fifth one? The fifth one, I think let us keep them in order to be very clear. Fourth one are called as instance-based algorithms. And here we might call dimension. I think we, instead of calling dimensionality, we can okay, call dimensionality reduction algorithms. Then we have clustering. I think let us group them in some category. Neural network. Just algorithms. Okay. So as of now, we will restrict ourselves to discuss these types of algorithms. Now you should get an idea. Now when if I say that we are discussing the types of algorithms in ML, generally any algorithm, if you take, for example, during Vector series, we took an algorithm called as KNN, right? And if I'm not wrong, you might have already gone through some algorithms types called as naive-Bayes classification algorithm, right? And during a Vector series, we saw an algorithm called as LogiBoost, right? which I said it is a classification based on regression concept, right? So there are fundamentally these are the basic type of algorithms based on which our ML tasks depend on. For example, classification, clustering, then neural network based task of classifying, rule prunings. There are a lot of ML tasks which we'll slowly discuss one by one. But let us discuss this algorithm, the type of algorithms. So when we discuss the type of algorithms, these all are coded, and mostly these all are algorithms. They are part of standard ML framework of any ML tool. For example, Veka, yes, you do get algorithms based on this. And if you take scikit, it comes there. If you go for keras, yes, there too you get some implementation of these algorithms. So every ML framework and toolkit gives you pre-built implementation of algorithms based on this type. So let us look at one by one. The first type of algorithms are based on regression. So as you all know that these algorithms basically work on principle of regression. Like the principle of regression means, let me explain you. For example, you all know the linear regression. Now, if I say that I am doing a classification using regression, for example, let us call it as logistic regression. When I say logistic regression, let us suppose if I have this two and I have some points. I think we discussed this already in some another lecture. And if I have this few points, and I want my classifier to classify between the circle point and cross points. So my algorithm has to guess a separation between two. For this example, if you see here, the points are scattered in such a way that a one linear equation line can easily separate that a specific instance lies in this class, and let us call it as class C1, and let us call this as class C2. So it can easily classify between these two. So what is separating? A line. So if you can guess this line, by using regression, you are able to classify these 2 points. So this is a basic principle on which classification based on regression works. And in short, we also call them as classification based regression trees. We have something called as CART algorithms as well. So these are some types of algorithms whose fundamentally they based on regression. So internally what they do is they do not classify. They try to guess some linear equation, a linear line, linear plane for a multidimensional set of points. So these are called as regression based algorithms, right? So in Veka we use an algorithm called as logic boost. I think it is called a logic boost. Okay, so this is something which is based on regression based classification. Okay, so the second type of algorithms are called as Bayesian algorithms. Now this might not be first time you are hearing the word Bayesian. You might have already learned in some BI data, some another courses, like even in I think AI you might have heard about Bayesian. So Bayesian algorithms are nothing but they are some algorithms which are based on the concept of Bayesian learning, or in other words, I can call it as they are something based on probability. So for example, if there are the points, instead of guessing the line, they calculate a probability that a given point belongs to cross type of points or circle type of points. So fundamentally, these algorithms are based on learning prior probabilities and posterior probabilities, which is based on Bayesian theorems. So basically, these are classifiers. All these algorithms under this, they are classifiers, majorly classifiers, and they are based on concept of probability. So we will look at one such concept of Bayesian learning in detail. We will see how a Bayesian concept is applied to machine learning. So people also call it as probabilistic reasoning and probabilistic learning as well. So there are multiple terminologies, but this is the terminology which our textbooks use, your syllabus and textbooks use, Bayesian based learning. Now, third type of algorithms are decision tree based learners. So when I say decision tree based on learners, what they do is they try to learn based on construction of a tree from the given data set. So for example, if I consider the same points, and if I say that this is y, okay, let us say if this is some y, and this is some x. So you can say that, um, okay, so let us call it as, so if I call this as feature value, so this is something called as mm, okay, let us consider these are features, and on this here we have label. Okay, and if this label is from 0, 1, and 2, these are the boundaries. For example, this is 0, 1, and 2, some kind of line. So you can say that whenever, so all value, whenever x is between 0 to 1, they come under one group. And whenever x is in between, whenever this value, the value on x-axis is between 1 and 2, these points go into another class. So what does the decision tree based learners do is, whenever you get this point, whenever you get during training, when this process receives this, it checks the value. What is the x value of this, and what is the y value of this. So based on x and y value, it will start constructing a tree. For example, it will first put a value. It will say value less than 1, then it says that C1. If it is no value is not less than 1, it might put this into C2. So this is simple tree based learner which I've said. Some, if I have multiple features, for example, it might have a z axis, then here it might have one more condition. Like if z is less than 1, then it will say C2, or it might have some C1, and we might have multiple classes as well, C3 we have. So the fundamental principle of classifying in these types of algorithm, decision tree based learners, is based on building a tree. So where each node acts as a one condition. So any new instance, it gets evaluated in these conditions, and it ends up at some leaf node, which defines the class to which the new instance belongs to. Okay. So here these algorithms, the main goal is to construct a tree which can now predict the class for a newer instances. These are called as decision tree based algorithms. And frankly speaking, these are very popular, and these are used very extensively in real world applications as well. So now you can tell me, for tree based learners, can you tell me that what is better for it, when the features are numeric or nominal? So tree based learners, they perform better when your features are usually numeric. If you have a numeric, it can compare, it can learn more, it can learn the ranges, and it can compare well. Okay, so these are called as decision tree based learners. And next type of algorithms are called as instance based algorithms, and these instance based learners are also called as lazy learners. Okay, why we call them as lazy learners? So these are something, what they do is, given a new instance, whenever we have a new instance, what they do is they compare this new instance with existing training data. Whatever the training data which you have, this new instance is compared to this training data. Then its similarity is compared. Based on that, they predict it. So what they do is they do not train in well ahead. Okay, are you getting that? So they do not train well ahead. So what they do is, specifically they are used when you want to categorize new data points based on similarity to the training data. And these are called as lazy learners because technically, going on technical terms, there is no training in this. So it just has a data. Even if you do training on this, it keeps the data in well organized and structured format with respect to its algorithm's internal working. And whenever a new instance appears, it just compares that with the training data, and then it gives its output. So that's why we call this as lazy learners. And one of the best example of this algorithm which we have used is KNN, K nearest neighbor. So maybe it will take a training data, and if I say if k value is 3, based on three nearest neighbors, whichever are three nearest neighbors nearest to this new instance, and to whichever class these three nearest neighbors belongs to, that becomes the class for this new label. Okay, it works on that principle. So we call it as k nearest neighbors. Are you getting why we call it as instance based? Because any new data which you feed to this model to predict for you, what they do is instead of training, they compare that with your existing data and they predict. So they will look, is there any similar instance record in my training data and to whatever label it belongs to, that is output. So that's a very vague definition, but internally it has some way of working. So technically what people say is that they do not do any training. So training is always when a new instance appears, and based on comparison it gives that. A best example of such kind of algorithm is k nearest neighbors. Okay. And then we have something very complex, which where we go to dimensionality reduction algorithms. As you know that, so whenever we go for ML mode, if I have F1, F2, F3, let us suppose so on, I have till F50. So do you think that applying all 50 features might be a good task? It may be or it may not be. And sometimes see the features and this, whenever you have this, and when you plot it on let us say when you plot it on some geometric representation, some features can be fit into 2-dimensional, some features requires 3-dimensional, and some might require 4-dimensional, 5-dimensional, and some might require very complex 6-dimensional representation in that. So more the dimensions of the data, complex will be the machine learning. More the complex, more the chances that data might overfit and it might give into high variance. So what we do is we apply some algorithms. What they do is they convert this data into lesser dimensional representation. Okay. So for example, if I have a 3-dimensional data, I can convert the 3-dimensional data into 2-dimensional by applying some parametric conversions. Like I don't know if most of you have been in through M1, M2, M3, and M4, you will see that something called as parametric equations. So some x is equal to y, for example, x is equal to y plus 3 and all this. This can be represented as t is equal to sine theta, a sine theta, and b sine cos theta or something. So we can convert a 3-dimensional data representation into 2-dimensional data representation as well. And when you're converting this 3-dimensional data into 2-dimensional data, there should be no loss of information, and these transformations should be reversible. I mean, at any moment, if you want to go back to your 3D representation, you should be able to go that. Okay. For example, the best example of 3D2 is your computer graphics simulations. So actually speaking, everything is 2D, but somehow the third dimension is represented with the help of Z coordinate with 45-degree angle, and whatever points you take, and you can apply the matrix transformations on this, right? So this is a very good example of dimensionality reductions, and very complex data need dimensionality reduction, and then we apply for this one. So one of the best example is PCA, Principal Component Analysis. There is one standard algorithm which you find it in Veka and Scikit and every other machine learning toolkit and framework. So whenever you find someone using PCA, what he's trying to do is he's trying to reduce the dimensions of data. And these algorithms are specifically under dimensionality. And we have neural network based algorithms. So neural network based is based on concept of neural networks, and so any classification algorithm which is based on neural networks, uh, the basic algorithm is based on weights multiplied by weights. So summation, we have activation functions, and then we have an output. Okay, so that's how the neural network works. I think I'll not go very deep into this, but it's fairly simple. Every edge has a weight. So whatever the terms you get is weight into the edge cost. Whatever you have, it gets sum. So summation of wi into edge cost. So then it decides whether to activate or not. Then we have activation functions like we have sigmoid, tan h, we have cos h functions. The various activation functions, ReLU. So these activation functions, they activate this line based on this. So it is some kind of brute force kind of training approach where eventually these weights and the costs are learned, and you start getting the output at your output nodes. So all these algorithms come under neural network. For example, deep learning, NST, LSTM, CNN, convolutional neural networks, RNN, recurrent neural networks. These all are algorithms which are fundamentally based on representing the learning model as a neural network, which is inspired from the human way of learning. That's it. And then the last are clustering algorithm. These are something which we use in unsupervised fashion. I mean, there is no labeling or any training. You pass the data to it and they output some patterns, which most often include clusters or outlier detections or anomaly detections. So such kind of tasks are better done using clustering algorithms. So famous example of clustering algorithm is k-means, and we have so many different as for we have ID4, ID3, I guess, many other clustering algorithms. I don't recall the exact names of algorithms which I can state here, but fundamentally they are used for unsupervised. So you might ask me, where do we apply unsupervised? So unsupervised is sometimes applied on data processing, and we do have some very specific applications where unsupervised works better. For example, let's say fraud detection, or let's say we want to find out outliers or anomalies, like something very odd case appears in the data, or sometimes clustering algorithms are also used for noise removal as well. So suddenly it just identifies something where some from the all the data set, suddenly some value is very high. So such odd values, unsupervised, these algorithms are better at identifying these noises. So that's the area where we use clustering algorithms often. Okay. So I hope you got an idea. Like, so any algorithm which we take, we look on these types. And why does it matter to learn types of algorithms? Because see, when we were looking at improvements and when we were looking, if you recall our Veka series, the moment we changed algorithms and some hyperparameters, accuracy jumped from 30% to 54, 55%, right? So understanding what is inside data and what pattern I want to learn, and knowing how this algorithms works, which this might help you understand what algorithm might be best for this task. So if you understand this algorithm types, instead of trying all 7 types of algorithms, you can shortlist your choices. Like, okay, my data looks like more a probabilistic approach, so I will apply either Bayesian learning or decision tree or 2, 3, 4 instance based algorithm. That's it. So you will get some good amount of idea to decide on shortlist what kind of algorithms might be best for your model. Okay. So I hope you understood these types of algorithms. So now what we will do is slowly, when we now henceforth when we start doing some quick hands-on or something, or when we try some Kaggle data sets, so we will take one of the algorithms, we will decide how to come to the choice of algorithm. So we will do some exercises where it will be very clear to you. There we will invoke this understanding once again. Okay. I think I am fine for this session. Just let me know why attendance was less today. So I think you can, if you do not have any questions, you can mark your attendance and you should be fine to leave. Okay. So I think Lalit, you are saying that link is received slowly. I think. Okay. Yeah. So what I'll do is I will invite and I'll put the link in Telegram group also.